This is a different kind of problem. We will in this video will prove that one and only one out of n plus 2, n plus 4 is divisible by 3. What does this mean? It means that if n is divisible by 3, then n plus 2 or n plus 4 will not be divisible by 3. Or if n plus 2 is divisible by 3, n and n plus 4 will not be divisible by 3. So that's what we want to prove, that among n plus 2 and n plus 4, only one of them is divisible by 3. Correct? Here it is given that n is any positive integer. So since n is any positive integer, we will take and we want to prove that it is divisible by 3. So we will take what happens when n is divided by 3. So again we get q and remainder r. So possible values of r are 0, 1 and 2. Again we get 3 cases here. So case 1 is n is of the form 3 into q, correct? And case 2 n is of the form 3q plus 1, and case 3 n is of the form 3q plus 2. So what we have to verify is if I take n as 3q, among n plus 2 and n plus 4, we want only one of them to be divisible by 3. If I take n as 3q plus 1, again among n plus 2 and n plus 4, we want only one of them to be divisible by 3. Let's see as and how we solve, we will understand better. So let's take n as 3q. So we want n. So n is 3q. So this is 3q, and this number is divisible by 3 because remainder 3 into q and the remainder part is 0. So therefore this number is divisible by 3. So let's take n plus 2. If I take n plus 2, this now becomes 3 into q plus 2. Now if you see 3 into q plus 2, this is the remainder part. So now the remainder is 2. Since the remainder is 2, this essentially means that n plus 2 is not divisible by 3. Please write the reason. In your answer you have to write the reason. Since the remainder is 2. For one I will write, for remaining you follow yourself. Okay, since remainder here is 2, here is 2, n plus 2 is not divisible by 3. So we proved that n is divisible by 3, but n plus 2 is not divisible by 3. Let's check for n plus 4 what happens. So when I take n plus 4, this becomes n is 3q, so 3q plus 4. So 4 is again an interesting number. We did this one earlier. Since I want 3 outside, I can write 4 as 3 plus 1. So I will write 4 as 3 plus 1. Now between these two, I can take 3 outside. So remains q plus 1 plus 1. Since q is an integer plus integer is now another integer m plus 1. So what happened here? N plus 4 now is of the form 3m plus 1. Now the remainder part here is 1. Again the same reason. Since the remainder is not 0 or the remainder is 1, n plus 4 is not divisible by 3. So what did we prove? If n is of the form 3q, n is divisible by 3, but n plus 2 is not divisible by 3, n plus 4 is not divisible by 3, which means only one of them is divisible by 3. True. Let's see if in this case if it is true. So let's take first case n is 3q plus 1. Directly 3q plus 1. So 1 is the remainder. So n is not divisible by 3, definitely. Let's take n plus 2. So when I take n plus 2, n is 3q plus 1 plus 2. So this is of the form 3q plus 3. So 3q plus 3 meaning I can take 3 outside. So it is q plus 1. Q plus 1 is again an integer. I can write it as 3m. So it is 3 into m plus 0. So plus 0 meaning the remainder here is 0. So if the remainder here is 0, now n plus 2 is now divisible by 3. So we proved that n is not divisible by 3. N plus 2 is divisible by 3. We will check for n plus 4. So what we want? We want n plus 4 to be not divisible by 3. So let's check if it is true. So when I take n plus 4, so n is 3q plus 1 plus 4. So it is 3q plus 5. Again, since I cannot take 3 outside, 5, we will write it as 3 plus 2. 3 plus 2. So now between these two, I can take 3 outside. Remains q plus 1 plus 2. q q plus 1 is again an integer, so it is 3m plus 2. Now the remainder here is 2, which means when I take n plus 4, the remainder is 2, therefore n plus 4 will not be divisible by 3. So what again we proved, between n plus 2 and n plus 4, there is only one number that will be divisible by 3, the other two will not be divisible by 3. Let's take the other form. So n is 3q plus 2. So again let's check, n is 3q plus 2. Directly the remainder is 2. So therefore this number is not divisible by 3. Okay. So let's check n plus 2. So if I take n plus 2, this will become 3q plus 2 plus 2. So which is 3q plus 4. Since I cannot take 3 outside here, I will write 4 as 3 plus 1. So again I can take 3 outside. So remains q plus 1 plus 1. Q plus 1 is an integer. So it is 3m plus 1. So 3m plus 1, the remainder here is 1. Since the remainder is 1, this number is now not divisible by 3. So we proved that two of them are not divisible by 3. So when I take n plus 4, that number has to be divisible by 3. So let's check that one. So n plus 4. So 3q, n is 3q plus 2 plus 4. So it becomes 3q plus 6. Now between these two I can take 3 outside, remains q plus 2. Q is an integer, 2 is an integer, so resultant is again an integer. So it becomes 3 into some integer m. So again, since the remainder is 0, this number is now divisible by 3. So what did we prove? Among all these 3, only one of them is divisible by 3 and the other two are not. In all the cases, it is true. Does not matter which positive integer you take, only one of them, n plus 2 or n plus 4 will be divisible by 3. I hope this problem is clear.